So F test for slope coefficient, and we have just said there's ANOVA, but we didn't actually relate ANOVA. But remember ANOVA, we do F test to test whether grouping has meaning. So here the same, we will say that with F test to see whether the beta coefficient, which is slope, is equal to 0 or not, has meaning or not. And we will SSR over 1, degree of freedom, SSE divided by n minus 2, will follow this F distribution with degree of freedom 1 and n minus 2. So we should prove it, and this is actually related to t test, okay? And actually t square is equal to the F, okay? We'll show it at the next two technical slides. So first we have to make our life easier. Next is a shorthand notation. Sxx is sum of square with x. Okay, Sxy is a cross product of the xi minus x bar, yi minus y bar. Okay, and first t, remember the t test, right? Is beta with beta bar, beta hat minus 0, and the SE of beta hat. This, if you use this notation, right? Beta bar with Sxy over Sxx, and this SE hat will be S, right? So estimate the standard deviation of the residual, right, over the square root of Sx, right? And this, they cancel out, will be square root of Sx, right? Will be Sxy over square root of Fx and over S, right? And t squared will be equal to this fraction, okay? And the next slide will show why the numerator can be written this way, but denominator S squared, right, will be the residual estimate standard error of the residual, right? So that will be y hat minus y squared divided by n over 2, right? This SSE to n minus 1, and this is SSR, right? So now what remains is to show, okay, the numerator of this is correct, so will be next slide. So yi minus y bar, okay, and yi hat will be equal to alpha hat plus beta hat, right? And then alpha hat, right, will be y bar minus beta hat x bar, okay? Y bar and y bar cancel out, right? And beta hat can be taken out, okay? Because square is taken out square. What you left is xi minus x bar square, okay? And then this actually is sxx, right? Beta hat will be sxy square over sxx square, okay? Square cancel out will be sxy over sxx, right? Actually this one equal this one, this what I want to show. And so that's why this is equal to this, and this is exactly the f, because you know t square, right, of n will be equal to z normal CO1 chi square n and over n, right, square, and this z is x square, right? Z square is a chi square degree of freedom 1 divided by 1, right? And this actually is a f distribution of degree of freedom 1 and n. Okay, so that's why we cover the relationship between f test and t test here. Okay, that's the end for this part.